Hey ladies and gentlemen, this is Miss Humbert here. So today we're going to be talking about notes 4, which is adding and subtracting polynomials. Now if you remember the very first notes video we did, we talked about combining like terms. We said, okay, we said that x squares were going to be represented by squares. So here I have 4 squares. And then x's were going to be added by lines. So here we have 3 lines. 1, 2, and 3, and so forth. So I'm not going to go through and finish all of this up. But the purpose of when we did this activity was that squares could not be added with lines. They were different. Okay, so because of that, we needed to only add squares to squares and lines to lines. Now that's a concept that's going to be very, very important today. We just spent 2 days doing the rules of exponents, so now it's important that you remember back to that first note video when we talked about combining like terms. So let's take a look at adding and subtracting polynomials. So first of all, when you add a polynomials, you can group them horizontally or line them up vertically in columns. So write down what you need to know to help remember these kind of things. And we'll talk about each of the ways of adding and subtracting polynomials here in a second. So basically when you're adding polynomials, all you're doing is combining like terms. Okay, you want to make sure that your exponents go from largest to smallest. That's that idea of putting it into standard form. So let's go ahead and take a look at just some simple combining like terms, just to review that. So when we combine like terms, we always started by looking for the most amount of the largest exponent. So in this first one, I see that 4x cubed is our largest exponent. So when I go to add those two terms, I'm going to add the coefficients, but I'm going to keep the exponents the same. When you are adding terms, you do not add the exponents. You only add the coefficients. Our next highest exponent is 8x squared minus 5x squared. So 8 minus 5 is 3. Okay, so we're adding the coefficients, but we're keeping the exponents the same. Next, negative 3x plus 5x. Again, adding the coefficients, keeping the exponent the same. And last but not least, 8 minus 12 for our constant is negative 4. So we have 7x cubed plus 3x squared plus 2x minus 4. Let's take a look at number 3, combining those like terms. So we have 3, so first 5x to the 5th, that's our biggest. And there's only one 5x to the 5th, so we don't have to add that to anything. Next, 3x cubed minus 2x cubed. Again, adding the coefficients, keeping the exponents the same. That's going to give us x cubed. Then we have negative 2x minus 4x. That's going to give us a negative 6x. When you add two negatives, it's going to get more negative. Last but not least, 4 plus 5 is going to give us 9. Let's take a look at a couple more. Adding these ones together, I see my highest exponent is x cubed. So I have 3x cubed plus 2x cubed. That's going to give me 5x cubed. My next highest exponent is squared, 2x squared plus 5x squared. Again, just adding the coefficients, keeping the exponent the same. Negative 3x is next. And then negative 12 minus 6 is negative 18. So I want you guys to go ahead and try number 4 on your own. Let's take a look at some of these methods. So the first method is the horizontally. So we're going to line our terms up straight across, and then we're just going to combine like terms, kind of like we just did in the previous problem. So for this one, we take 4x squared plus 2x squared, which is 6x squared. 2x plus 3x plus 2x, which is 5x. Negative 2 plus 1, which is negative 1. The next method is the vertical method. I prefer this method simply because it lines it up really nice for me. It's almost kind of like using elimination. Okay, so you're going to line the terms up vertically, putting the like terms into columns. So here I have a squared column. Here I have an x column. Here I have a constants column. And then we can just add down the columns. So 4x squared plus 2x squared is 6x squared. 3x plus 2x is 5x. And negative 2 plus 1 is a negative 1. So both of those are options. I'm not going to make you do one or the other. Do what's comfortable for you. I usually tell students to pick a method and stick to it. All right, so let's go ahead and let's take a look at number 5. So for number 5, we're going to be adding those. So when we're adding them, we want to see if we can go ahead and we can pick our method. So I'm going to start by just using the horizontal method to start off with. Okay, so I'm just going to start by doing the horizontal method. So that just means combining like terms. So I have 3x and combine those to be negative 4x squared. Sorry about that little blip there. My computer kind of had a mental breakdown. All right, then we have negative 4x plus 2x Add those two together and you're going to get a negative 2x. Last but not least is 8 and negative 5. So that's the same as 8 minus 5, which is 3. Let's take a look at doing number 6 using the vertical method. So we have 5x squared minus 3x plus 4. So lining those up. So for this one, I want to put that negative 3x in my x squared column, my 6x here, and my minus 3 here. And then I can go ahead and I can add down the columns. Well, 5x squared minus 3x squared, that's going to give me 2x squared. Negative 3x plus 6x is going to give me 3x. And 4 minus 3 is going to give me negative 1. You could have also doing this the horizontal method. Again, whatever method works best for you. All right, so let's take a look at this next one, subtracting polynomials. When you're subtracting polynomials, you're going to go through and change the signs of everything after the minus sign. So there's going to be a minus sign. There's going to be a parenthesis that follows. So you need to change everything in the minus sign afterwards. Okay, so let's go ahead and let's take a look at what that's going to look like. So next, okay, let's line this up. So first, I'm going to use the vertical method. So I have 4g cubed minus 5g. And I'm subtracting off this entire thing right here. So when I subtract that off, 2g cubed plus 4g, I want to take a look at that as changing the signs of everything that follows in the parenthesis. So I tell students you should physically go through and change the signs. A lot of students think, oh, hey, I'll just remember how to do that. I'll remember. And a lot of times they forget by the last term because they're trying to do so much in their head. So I really suggest to students that they actually take and subtract everything out. Okay, and change the signs. So 4g cubed minus 2g cubed gives me 2g cubed. Negative 5g minus 4g, again, that's going to get more negative, and that gives us 9g. So this right here is your final solution. Let's take a look at number 8. So for number 8, we have 3n squared plus 13n cubed plus 5n. Well, I'm going to rewrite that guy out. So let's just kind of start over, and I want to put it into standard form. So I'm going to put my n cubed first, then my n squared, and then my 5n. So now I'm going to subtract this second guy off. So I'm going to line it up under the columns. So I have something under here. I don't have an n squared term, so I'm going to leave that blank. And then I have this 7n that I'm currently adding. Well, because I'm subtracting it, I want to take and change the signs of everything. So 3n cubed minus 4n cubed is a negative 1n cubed, or just a negative n cubed. Don't forget about this column. You do have to bring that 3n squared down to the bottom. And then 5n minus 7n is a negative 2n. So that right there is your final answer for that one. Okay? Next, let's take a look at number 9. So for number 9, what we want to do is we want to, again, I'm going to set it up horizontally. For me, that's easier with subtraction. So I have 5y squared minus 3y plus 8. And now I'm subtracting, I'm going to have my y squared column and then my constants column. I don't have a y column. So now I want to take and I want to distribute in that negative. So I remember that each of those terms are being subtracted. 5y squared minus 4y squared is just y squared. Bring down that 3y. We don't want to forget about it. And then 8 plus 9 is going to give me 17. So that's my final answer for number 9. I want you guys to go ahead and try number 10 on your own. All right, let's get this word problem set up. So it says the total number of public school teachers T consists of two groups, elementary E and secondary S. From 1992 to 2003, the number in thousands of secondary teachers and total teachers could be modeled by the following equations. So it wants us to find the number of elementary school teachers. Well, here's the thing. We know the number of secondary teachers and we know the number of total teachers. So in theory, the number of elementary school teachers would be equal to the total number of teachers minus the number of secondary teachers. So let's go ahead and now let's plug that in with what we know. Okay, so plugging it in with what we know. So we have our elementary school teachers is going to be equal to our total, which is 58N plus 2,401 minus our secondary, which is 29N plus 949. So now we want to take and we want to distribute the negative. So let's do this using the horizontal method. So I need to make sure that that minus sign gets distributed into everything in that problem. Okay, so I have 58N plus 2,401 minus 29n minus 949. Okay, so now that we've subtracted those, so now we're going to combine like terms, 58n minus 29n. So this is for our elementary school teachers. That's going to give us 29n. 240 minus 2,401 minus 949, that's going to give us 1,452. And that's all you needed to do. You just needed to find the equation that represented the elementary school teachers. So that concludes your note video today. Please make sure you take that Schoology quiz.